New geopolymers from industrial byproducts of life, biomass, fly ash, and chamotte as raw materials. The research presents the feasibility of a geopolymer fully elaborated from chamotte, a waste from the ceramic industry, and olive biomass fly ash, a waste from the olive oil industry. A typical ceramic characterization was carried out from the mechanical and physical point of view, with the aim of exploring its potential as a construction material to reduce these wastes currently in disuse and reduce clay extraction operations, according to the results obtained. Introduction. The amount of industrial waste is growing every year due to the excessive use of energy and natural resources. The recycling of industrial byproducts has become an inevitable necessity to ensure the protection of the environment, natural resources, and sustainable construction industries such as ceramics and cement manufacturing. Raw materials. The energy stored in biomass can be released to generate electricity through thermal combustion of biomass. Biomass combustion is a low-cost means of reducing GHG emissions and reducing air pollutants in existing power plants. The problems. The principal problem is cement manufacturing is highly polluting due to the large amount of greenhouse gases that are emitted into the atmosphere. Characterization of the raw materials. The percentage of carbon, hydrogen, nitrogen, and sulfur were determined using a commercial CHNES analyzer based on a dry combustion method for the analysis of organic substance. The elements chemical composition of the raw materials, Chamotte and OBFA, was determined by micro X-ray fluorescence using a high performance micro XRF spectrometer. These are some results of this laboratory, and the results and discussions was explained in the paper number 1 of this article. The X-ray fluorescence the same and have in this the pH determination. The pH value was calculated for the LBFA NC sample as well as for ABFAC at 900 grades. The pH value plays a paramount role since it is necessary for the alkaline solution to have a pH value above 12 to ensure the geopolymerization process. Characterization results of the CHOBFA represents the mass loss of the different specimens formed after the curing process at a temperature of 85 more or less 5 grades for 24 hours. Weight loss, dimensional determination, and linear shrinkage from the previous tests performed of the different families of specimens. The optimum configuration of the geopolymer was selected based on the criteria of maximum compressive strength value. And the conclusions: the feasibility evaluation for the use of fair clay by fly ash and olive biomass as a precursor solution and alkaline activator, respectively, was determined by their psychotechnical characterization test of the materials, which show compatibility between both treated raw materials, and the bibliography is the same of the first paper, that is the article.